All right, I've had a question from Unit 2, Lesson 1, and it's question number 8 from the homework, linear combinations of vectors. So, just a quick how-to on the A part, and then I'll talk about B and C. So if we look at 8A and point I, we want to know if these vectors can be written in that form. So basically we're asking ourselves, can 4, 2, 2 be written as M211 plus N negative 1, 1, 3. So what we do is we look at the first one. So we're going to look at our x component. So 4 equals 2m minus n. Look at my y component. 2 equals m plus n. And what I'm going to do is I'm going to solve for m and n using these two equations. So therefore, 4 equals 2m minus n. 2 equals m plus n. So I'm going to add these together. 6 equals 3m plus 0n, which means that m equals 2. So then we go over here, we check our z component to see if that works. So my left side is equal to 2, and that's from the original or the point in question. And then we have m plus 3n. So I'm going to have to figure out, backstep a little bit here and figure out what n is. So if m equals 2, if I go into this one, 2 equals 2 plus n. So that tells me that n is equal to 0. Now I can check this. So I'd have 2 plus 3 times 0, 2. Left side equals right side. Therefore, the point 422 can be written as a combination of u and v. Now, the question that really came in was about parts B and C. So part B says find another vector that can be expressed as SU plus TV. So that is simply just, you can almost do this off to the side here. So B part, all we're doing is we're creating a new vector. What was it, SU plus TV. Well, we can just pick whatever variables or values we want because it says create any equation. So if I let s equal 1 and t equal 2 for argument's sake, my new vector w will be 1, and it'll be 2, 1, 1, plus 2 times negative 1, 1, 3. So there'll be an infinite number of answers because you can pick whatever values of s and t you want. So we'll end up with a new vector of 0, 1 plus 2 is 3, and 1 plus 6 is 7. So there is the answer to B part, or one possible answer to B part. So find another vector that cannot be expressed. So if I do take that, I need a little bit more space for that. So if I here, so I believe the u vector was 2, 1, 1, and negative 1, 1, 3. Right? So these vectors, this is the easiest or quickest way I would think to find a vector that cannot be written. We know that these two vectors u and v, we can assume they're coplanar. So the u vector points this way, v vector maybe is over here somewhere. What I'm going to do to make sure I have a vector that's not going to work here, I'm going to create a vector that's perpendicular to this plane, and we'll call it vector m, for example. So if I find a vector perpendicular to both u and v, they definitely cannot be written as a combination because u and v, think of u and v's on the piece of paper. They can only move you on the piece of paper if I have a vector that's not on the piece of paper, like m coming out perpendicular, then it can't be written as a combination. So how do I find that vector m? Well, I do that by using our cross product for the first unit. So u cross v. So off to the side here, quickly figure that out. Oops, that should be 3. 3. So my new vector would be 3 take away 1, so it's 2. And then negative 1 take away 6. And then 2 plus 1 is 3. So therefore, m vector is perpendicular to both u and v. So therefore, m cannot be written or equal su plus tv. All right, and the reason for that is right there, that it comes off the page or is perpendicular. So hopefully that explains how to do parts B and C for question number 8. If you have any other questions, let me know, and I can try to clarify.